Next, let us go to the matrix matching type question. Column 1. A. The roots of the cubic equation z plus alpha beta whole raised power 3 is equals to alpha raised power 3, where alpha is different from 0, represent the vertices of a triangle of what area? And B is, if alpha is a complex number, then the radius of the circle represented by z minus alpha by z plus alpha mod is equals to 2 is. And C is, if argument of z is alpha and mod of z minus 1 is 1, then z minus 2 by z modulus is equal to how much? And let A and B represent the complex numbers z1 and z2 respectively, which dBTs. Let A and B represent the complex numbers z1 and z2 respectively, which are the roots of the equation z square plus pz plus q equal to 0, and angle AOB is alpha on the orgone plane OA equal to OB, where on the horizon the p square by q value is how much? And under column 2, p is given as mod tan alpha, q is given as 3 root 3 by 4 mod alpha square, r is 2 by 3 alpha minus alpha bar modulus, and s is given as 4 cos square alpha by 2, and t is given as alpha plus alpha bar square. Let us find what is the correct match for this column 1 to column 2. First of all, let us proceed to the item A, under which you are given with z plus alpha beta raised power 3 is equals to alpha cube, which can be written as z plus alpha beta is equal to alpha if you take cube root on both sides. That is cube root on both sides, then you will get z plus alpha beta is alpha, and omega alpha and omega square alpha from the definition of cube roots of unity. Thereby you can find out z as alpha minus alpha beta and omega alpha minus alpha beta and omega square alpha minus alpha beta as the three roots of this z. Say, let me take this one as z1, let me take this as z2, let me take this as z3. Let us consider. When you consider this one, then these are the z1, z2, z3. z1 comma z2 comma z3, these are representing the property like modulus of z1 minus z2. If you take z1 minus z2, then obviously this is equal to root 3 alpha, and if you take modulus of z2 minus z3, this is also root 3 alpha, and modulus of z3 minus z1 is also equal to root 3 alpha. When they are possessing this property, obviously the z1 and z2 and z3 represents an equilateral triangle. And let us consider there is A of z1 and B of z2 and C of z3. These are the vertices of triangle ABC. When they are the vertices of triangle ABC, and the area of triangle ABC, which is an equilateral, is root 3 by 4 into side square, which is equal to root 3 by 4 into side is this one, that is root 3 alpha square, which is equals to, this is 3 root 3 by 4 alpha square is A. So A will match to 3 root 3 by 4 alpha square modulus A will match to Q. So that is first match. Next, let us go to B bit. Now in B bit we have mod of z minus alpha by z. The B bit we have z minus alpha by z plus alpha equal to 2. So z minus alpha by z plus alpha equal to 2 can be written as mod of z minus alpha square is equals to 4 into mod of z plus alpha square. Implies mod of z minus alpha by mod of z plus alpha is equals to 2 is written as mod of z minus alpha square is equals to 4 into mod of z plus alpha square. So if you expand this, this becomes z bar minus alpha bar z minus alpha z bar plus alpha bar is equals to 4 times of z bar minus 4 times of alpha z and minus 4 into alpha z bar plus 4 into alpha bar. If I simplify this, then I can get the equation as 3 times of z bar plus of alpha minus 4 into alpha bar times of z bar plus alpha bar minus 4 times of alpha into z plus 3 times of alpha bar equal to 0. Finally, this can be written as z bar plus alpha minus 4 into alpha bar by 3 into z bar plus alpha bar minus 4 alpha by 3 into z plus alpha bar is equal to 0. So this is the locus of a circle. If it is the locus of a circle, then The radius of the circle is got by the formula root over alpha minus 4 alpha bar square over 3 minus alpha alpha bar, which can be simplified to get 2 by 3 mod of alpha minus alpha bar. So therefore B is matching with 2 by 3 alpha alpha minus, that is R. So B matches with R. This is second match. Now let us go to the C, where C goes. Now here let us consider Z is equals to X plus Iy, where mod of Z minus 1 equal to 1 becomes mod of X minus 1 plus Yi equal to 1. That is nothing but X minus 1 whole square plus Y square equal to 1. This is a circle with center at 1 comma 0 and the radius is equals to 1. So here if you go to the diagrammatic explanation, this is x-axis and this is yi and this is on the organ plane horizon. The circle might be in this way, which will be passing through the horizon whose radius, that is center at 1 comma 0 and the radius is equals to 1, and this might be the point P of Z where this will be the 90 degrees. If we consider this A as 2 comma 0, which is the extremity of the circle, and this is the diameter, this is the center of the circle. So therefore Z lies on a circle of radius is equal to 1 and the center is at 1 comma 0. So since angle OPA is equal to pi by 2, we can take it as 2 minus Z by 0 minus Z, which is equal to mod of 2 minus Z by Z into e to the power of plus or minus pi by 2i, where here Z minus 2 by Z is equals to some AP by OP from the definition times of plus or minus I, where this can be plus or minus I into from the definition in terms of if this is taken as alpha, that is tan alpha. Therefore modulus of Z minus 2 by Z can become is equals to mod of tan alpha. Hence C opt for the match P, that is P. And let us go for D goes to with. See here, from the given data, the Z1 and Z2 are the roots of the equation. Then sum of the roots is got by Z1 plus Z2 minus P, and the product of the roots is Z1 Z2 is equal to Q. And if you take Z2 by Z1, then that is equal to cos of alpha plus or minus I into sin of alpha from the definition, where I can get Z2 minus Z1 cos alpha by Z1 can be equal to plus or minus I sin alpha on simplifying both sides. Hence here if I find out the square, then I'll get Z2 square minus 2 into Z2 Z1 into cos of alpha plus Z1 square into cos square alpha, which is equal to minus Z1 square into sin square alpha. Thereby we can write it as Z1 square plus Z2 square minus 2 into Z1 Z2 into cos of alpha is equals to 0. Therefore this can be written as Z1 plus Z2 whole square can be written as Z1 plus Z2 whole raised power 2, which is equals to 2 into Z1 Z2 into 1 plus cos alpha by taking Z1 Z2 common. So if you substitute Z1 plus Z2 is P square, then obviously this becomes is equals to, this is P square. If I substitute minus P whole square, Z1 Z2 is Q, so P square by Q is equals to, this becomes 2 into 1 plus cos alpha can be written as 2 into cos square alpha by 2. Therefore 2 2's will become, that is 4 into cos square alpha by 2. So therefore option D matches with the rest of the thing, that is 4 cos square alpha by 2, that is S. That is S. So correct option you got is A matches with Q and B match with R and C match with Q and D match with S.